Hello students, this is a video on the topic tests available at Bodhee Prep. The topic tests are supposed to help you figure out whether you are ready with the concept or not. So once you have done the basic concepts of a topic, you refer to these tests to verify whether you are able to do these questions in the exam mode. With every test, there is a video. So once you have taken the test, you refer to the video that will give you the solutions as well as a brief analysis of how you would attempt this test if it were an exam, the kind of time that you would give, the kind of questions that you would choose. There are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description of the video. Please make sure you download the app and make the most of these tests. Now, this video is on integral solutions and inequalities topic. This is the fifth test in the series on this topic. The overall analysis for this test would be a moderate level of difficulty. About 6 to 7 questions net correct would be a 95 plus percentile, and the attempt time ideally would be somewhere around 21 to 24 minutes. Not saying that we do all the 10 questions in this time, but at least get our 6 questions correct and have gone through all the questions. If we look at each of the question, a rectangular floor is fully covered with equal square tiles. All the tiles of the on the edges of the floor are white, and the rest of them are red in color. The total number of white tiles is half the total number of red tiles on the floor. What is the maximum positive difference between the number of red tiles and the number of white tiles? Now, if we assume that the floor is such that the breadth is x plus 2, where x plus 2 is x is the length, or x plus 2 is the number of square tiles that can be put along the breadth. Y plus 2 is the number of bricks that can be square tiles that can be put around across the length. So now if we look at it, the ones on the edges will be white. So there'll be x here, one here, one here, x tiles here, one here, one here. Similarly, y on the corners one, y in the corners one. And in the middle, we will have x, 1, 2, 3, x rows and y columns of square tiles. Therefore, if you look at the number of white tiles, it will simply be x plus y plus x plus y, x, x, y, y, and the corner 4. That means white tiles is 2x plus 2y plus 4. The number of red tiles will be x rows and y columns, therefore x into y. According to the question, the total number of white tiles is half the total number of red tiles. So white is equal to red by 2, which means 2x plus 2y plus 4 is equal to xy by 2, which means 4x plus 4y plus 4 is equal to xy, which means this will be 8, not 4. Sorry. This is 4. The next number will be 8 multiplying by 2. And therefore, we can say xy minus 4x minus 4y is equal to 8. 4 and 4 is 16. Xy minus 4x minus 4y plus 16 is equal to 24. Adding 16 on both sides. Left hand side becomes x minus 4 into y minus 4. This is equal to 24. What is the maximum possible difference between the number of red tiles and the number of white tiles? Maximum possible difference between the number of red tiles and white tiles. Now, if we look at the possible values, x minus 4 into y minus 4 can be written as 1 into 24, 2 into 12, 3 into 8, 4 into 6. 24 will have 8 factors, 2 cube into 3, which is 3 plus 1, 4 into 8 factors. These are the 8 factors. In the first case, x will be 5, x minus 4 is equal to 1, y will be 28. In the second case, x will be 6, y will be 10, y will be 16, 12 plus 4. In the third case, x will be 4 plus 3, 7. Y will be minus 4 is equal to 8. Therefore, 12. In the fourth case, x will be 8. Y will be 6 plus 4, 10. In these cases, number of white tiles would be 2x plus 2y plus 4. So 10 plus 56. 66 plus 4, which is 70. Red tiles will be x into y, which is 140. This is red tiles. If you look at the second case, 2x plus 2y, so 12 plus 32. 44 plus 4. White tiles is 48. Red tiles would be 96. In the third case, 2 sevens are 14 plus 12. 24. 24 plus 14, 36 plus 4, 40. Red tiles would be 7 into 12, which is 84. Clearly, they are half in each case. 80, not 84. This will be 42 then. 2 sevens are 14, 28. 14 and 24 is 38 to 42. White tiles here would be 8 to the 16 and 20. 36 plus 4, 40. And therefore red tiles would be 80. Now, when we are trying to maximize the difference between the number of red tiles and number of white tiles, and it is given that the number of white tiles is half the number of red tiles, the difference in all cases will be R minus W. W is R by 2, and therefore R minus R by 2 is equal to R by 2. To maximize the difference, we'll have to maximize the number of red tiles. Clearly, the number of red tiles is maximum here. And therefore, the maximum difference possible will be 40 minus 70, 140 minus 70, which is 70. I think a moderate level of difficulty question. Here the pattern would be visible, and therefore we won't have to check for all the numbers. Also, if we interchange the numbers, that is, we write this as 24 into 1, 12 into 2, the values of x and y will interchange, but these values will not change. Hence, 70 remains the answer. Question number 2 says ABCD exists such that ABCDs are integers and ABC is equal to D, BCD is equal to A, CDA is equal to B, and DAB is equal to C. If we multiply all of these four together, AAA 3 times, BBB 3 times, CCD 3 times, DD 3 times, we get ABCD whole cube is equal to ABCD. And therefore, one of the solutions is ABCD is equal to 0 or ABCD square is equal to 1, which means ABCD is equal to minus 1 or 1. This is what we are to solve for. Now, if ABCD is equal to 0 and we take one of the values to be 0 and put it here, ABC is also 0 because ABC into B into C is equal to 0. So, suppose C is 0. Now, if we put C as 0 here, D into A into B will make it 0. But if you look at the second case, BCD is 0, C into D 0 into 0 will be 0, therefore A also has to be 0. If A is 0, C into D into A will be 0, so B has to be 0. So one of the solutions for ABCD ordered pair will be 0, 0, 0, 0, and that is the only possibility when the product is 0. If you want ABCD to be 1, one of the possibilities, all the numbers are 1. We are solving for this. The other possibility is two numbers are minus 1. Can this happen? Suppose A and B are minus 1. A into B 1, ABC into D will satisfy. B into C into D will be minus 1, which is equal to A minus 1, which will satisfy. CDA minus 1 because A is minus 1, B minus 1 will satisfy. D into A into B minus 1 into minus 1 plus 1, so C will be plus 1 will satisfy. Now any two can be minus 1, so we can have AB, AC, AD, BC, or BD, or CD as minus 1s. If we want ABCD to be 1, either all have to be positive, 2 have to be negative, or all the 4 could be negative. Minus A, minus B, minus C, minus 1, minus 1, minus 1 is 1, minus 1, which is equal to minus 1. So the equation satisfies. Now, if we look at minus 1, then one of the values have to be minus 1. The other three have to be 1. In this case, we can see minus 1 into 1 into 1 will not be equal to 1 because D is 1. So this is not a possibility. one of the numbers being -1. If we take three numbers to be -1, A, B, C will be -1, but D is 1, therefore not possible. So this case will not give us an answer. So the number of ordered solutions are 1, 2, 3, 4, 5, 6, 7, 8, 9 becomes my answer. I think a relatively easy question. The attempt time might be higher for some of us, but the point is we're just checking for zeros and ones. So checking for these cases is not very cumbersome and therefore could be attempted. Number of integral values of x that satisfy mod of x minus 6 minus mod of x plus 3 is less than equal to 5. So first what we'll do is we'll remove the outer mod on the overall thing. If mod of x is less than equal to a, we can say that minus a is less than equal to the value under the mod less than 5. Now there are two critical points, 6 and -3. So we are making three cases. When x is less than -3, -3 is less than equal to x is less than 6, or x is greater than equal to 6. In the first case, both the mods will be negative. So -5 less than equal to minus x plus 6 minus plus x plus 3 will be less than equal to 5. Here x and x cancel out, so we get -5 is less than equal to 9 is less than equal to 5. This does not make sense. So no solution here. In this range of -3 to 6, the first mod will be negative, minus x plus 6. The second mod will be positive, so minus of x minus 3, minus sign remains as it is less than equal to 5, which means -5 is less than equal to minus 2x plus 3, subtracting 3 from the equation inequality throughout. -8 is less than equal to minus 2x is less than equal to 2. We have subtracted 3 from all the three terms. So this will give us minus 2x is greater than equal to -8 divided by -2. X is less than equal to 4, number 1. Second, this part will give minus 2x is less than equal to 2 divided by -2. X is greater than equal to -1. We were in the range -3 to 6. All these values are in the range of -6. So the values that x can take is -1, 0, 1, 2, 3, and 4. As we can see, these values are greater than -1, less than 4, and in the range -3 to 6. Put -1 here. -1 minus 6 is -7. So 7 minus -1 plus 3 is 2. 7 minus 2 will be 5. So this is the extreme value. Put 4 here. 4 minus 6 is 2. 4 plus 3 is 7. 2 minus 7 is -5. Mod of that is 5. -1 and 4 will give the extreme values. So we get these solutions. Now when x is greater than equal to 6, both the mods will be positive. X minus 6 minus x plus 3 minus x minus 3 -5, x and x cancel out, -9 less than 5 does not make sense. So no solution in this range. So the number of integral values of x is 1, 2, 3, 4, 5, 6. That becomes my answer. Overall, I think moderate level of question. Three cases to be checked, in which only one case has some amount of calculation. Therefore, 2 to 2.5 minutes to solve. How many integer values of x satisfy x minus 2, x plus 3, x minus 5 minus x? X minus 8 mod is less than 6. Now, I am not timing myself for what I'm going to do next. One is we look at the critical points, that is x is less than -3, -3 less than x is less than -3, -3 less than equal to x less than 2, 1, 2, then is 5. 2 less than equal to x less than 5, 5 less than equal to x less than 8, 5 less than equal to x less than 8, and x greater than equal to 8. So these are 5 ranges. In the first one, this will be negative, negative, positive, negative. Here we'll have negative, positive, positive, negative. Just put the value and check whether we are getting a negative value or a positive value. Between 2 and 5, this will be positive, positive. 5 minus 3 is positive. So positive, negative. Between 5 and 8, positive, 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 negative. This will become negative. 5 minus 6 is -1. Positive, positive, negative, and here it will also be positive. So we get these 5 ranges. You can open the brackets and get the overall curve. But I'm saying it is not needed. Since I know that the critical points are x is equal to -3, x is equal to 2, x is equal to 5, and x is equal to 8. Let us just look at the value of this fx at these terms or at these points. Here fx is equal to putting minus 3, we will get 5 minus 3 minus 2 plus 0. 5 minus 3 is 8. Minus 3 minus 8 is 11. This is 24. At x is equal to 2, we will get 2 minus 2 is 0. 2 plus 3 is 5. 5 minus 2 is 3. 2 minus 8 is 5. 5, 5. This is 6, sorry. 6 at 14. This is the value less than 6. At f is equal to 5, we will get 3 plus 8 plus 0 plus 3, which is again 14. And at f is equal to 8, we will get 6 plus 9. 6 plus 11 plus 3 plus 0, which is 20 something. So basically, if we plot the curve at minus 3, 2, 5, and 8, from 5 to 8, the value is constant at 14. At 3, it was 24, so it is decreasing till here. Then it is increasing, and then it is further increasing. So at x is equal to 16, we are looking at essentially 2 points. At 8, it crosses 16, which will lie between 3 and 2 and somewhere between 5 and 8. So just let us check for these two ranges. For x between minus 3 and 2, I will check. And I'll check for between between this and this. 5 is less than equal to x is less than 8 is what I'm checking for. In this range, minus 3 to 2, the first one. So to check, we'll just put the value of x as 0 and see whether the mod is positive or negative if there is any confusion. Because 0 lies between minus 3 and 2. So this gives me minus 3 and 2. Let x is 0. At 0, this is negative, so minus x plus 2. At 0, this is positive, so plus x plus 3. At 0, this is positive, so plus 5 minus x. At 0, this is negative, minus x plus 8 is equal to 16. So we'll get the value at where fx is 16. Minus x plus x cancelled. Minus 2x. 2 plus 3, 5 plus 5. 10 plus 18 is equal to 16. Minus 2x is equal to minus 2. X is equal to 1. So at x is equal to 1, we'll get the value as 16. From x is equal to 1 up till some point till here, the value of fx will be less than 16. So this inequality will be satisfied. In this range 5 to 8, if you put the value of x as 6, 6 minus 2 is positive, so x minus 2. 6 plus 3 is positive, so x plus 3. 5 minus 6 is negative, so minus 5 plus x, open it as negative. 6 minus 8 is negative, therefore minus x plus 8, open the mod is negative, is equal to 16. X minus x cancels, so 2x minus 2 plus 3 minus 5 minus 7 and 11 plus 4 is equal to 16, which gives 2x is equal to 12 or x is equal to 6. So at x is equal to 6, the value becomes 16. Between values of x 1 and 6, at all the points, fx will be less than 16 and the inequality will satisfy. So x can take values of 1, 2, 3, 4 or 5. It has to be less than 6 because at x is equal to 6, the value is 16. Hence, 4 integral values are possible. In terms of difficulty, it's just an easy question because we are just checking for the middle ranges for the answer, and therefore about 2 minutes should be good enough to get the answer. X, Y, Z are whole numbers, so could be 0, 1, 2, 3, anything. X is greater than equal to y. How many solutions are possible for x plus y plus z is equal to 36? Now, if I write x plus y plus z is equal to 36, and we are looking for whole number solutions, the whole number solutions will be 36 plus 3 minus 1, C3 minus 1, or 38 C2, which will be 38 into 37 by 2, which will be 19 into 37, which will be 740. 19 can be written as 20 minus 740 minus 37 or 703. Now, out of these solutions, there will be solutions where x and y can be equal. When x and y are equal, the values of x and y could be 0, 0, 1, 1, 2, 2, 3, 3. Correspondingly, we'll get a value of z, not important, till 18, 18, when z is 0. There are 19 possibilities. So out of 703 solutions, for 19 solutions, x is equal to y. Remaining 703 minus 10 minus 20. 683 plus 1, 684. For 684 solutions, x is not equal to y. There are two possibilities. Either x will be greater than y or x will be less than y. Because of symmetry, we can say there will be half and half cases. So 684 by 2, which is 342 cases, x will be greater than y. For 684 by 2, that is remaining 342 cases, x is less than y. We are looking for x greater than equal to y. So for x greater than y, cases is 342. X equal to y, cases is 19. So total number of cases becomes 342 plus 19, which is 361, option A. Again, combination is used. If we know that, solving this question becomes a lot easier. 2.5 minutes should be good enough to answer the question. X is greater than 2, y is greater than, which of the following statements is necessarily true? Put values and prove that the statement is false, so that it is not necessarily true. X and y is greater than -2. Take x as 1000, y as 0.5. So we have to prove less than -1. Take x and y as less than -2 is to be proved. Take y as minus 0.5, x as 1000. If we multiply, we'll get minus 500, which is less than 2. So this is not necessarily true. Minus x is less than 2y. Minus x is less than 2y. The minimum value that y can take is -2 and x can be 2. Again, let us check for C. X into y is less than -2, not necessarily. If x is 3, y is 2. X into y will be greater than 2. Minus x is greater than 2y. So we are checking one of these two values. If I put x as 5, minus x will be -5. And if you put y as 0, 2 into y will be 0. So minus y is less than 0. This is not necessarily true, and therefore B remains. That is my answer. Always try to prove false so that it is not necessarily true. If I had to solve this, I would say x is greater than 2, therefore minus x has to be less than -2, and y is greater than -1, multiplying by -1 here, multiply this by 2, 2y is greater than -2. So if we look at -2, minus x is less than this, minus, and 2y is greater than 2, and therefore we can say minus x is less than -2, which is less than 2y, and therefore minus x is less than 2y is my answer. Solving this question is also not very difficult, so about 1.5 minutes, easy question. If xyz is an ordered triplet such that 6x plus 5y plus 2z is 53, and xyz are positive integers, so have to be, cannot take zero values. What is the difference between the maximum and minimum value of x plus y plus z? X plus y plus z will have the maximum value when we maximize z, because z has the smallest coefficient, and typically will have the minimum value when we try to maximize x and y in that sense. So let us look at for the maximum value of x plus y plus z. Also, the minimum value of x, y, z has to be 1. So if we put this as 1 and 1, we'll get 6 into 1 plus 5 into 1 plus 2z is equal to 53. 2z will be 42, z will be 21. And therefore, the maximum value of y will be 1 plus 1 plus 21, which is 23. 23. Let us look at minimum value of x plus y plus z. Again, what we'll do is we can put 6x plus 5, y and z as 1. The problem is 5 plus 2 is 7. 7 minus 53. 53 minus 7. 53 minus 7 will be 46. 46 not divisible by 6. So we increase y. If we put y is 2, 6x plus 10 plus 2. Again, even will not be equal to odd. Again, further increase 5. 6x plus 15 plus 2 is equal to 53. So 6x comes out to 36, x comes out to 6. So minimum value is when x is 6, y is 3, and z is 1. 6 plus 3, 9 plus 1, 10. The difference 13, that becomes my answer. Easy question. All we have to do is maximize values on either of the extremes and check for the difference. The number of positive integer solutions of the equation 2 by x plus 15 by y is equal to 5. We can write this as 2 by x is equal to 5 minus 15 by y. or 2 by x is equal to 5y minus 15 by y, which means x is equal to, or x by 2 is equal to y upon 5y minus 15, which means x is equal to 2y upon 5y minus 15. We are looking at positive integer solutions. So clearly, y has to be greater than 3. Otherwise, this will be negative or not defined. Y can be 4, 5, 6, and so on. Also, if x is integer, we know that the denominator is a multiple of 5. As long as that does not cancel out, x cannot be an integer. Therefore, y has to be multiples of 5. So the value that y can take is 5, 10, 15, and so on. And these are my likely values where x could be integral. If you put x as 5, we'll get 2 5s are 10 upon 25 minus 15, which is 1. If you put y as 10, we'll get 20 upon 50 minus 15, 20 upon 35, which is not integral, less than 1, positive integral. Similarly, for all other values, if we look at this, if y increases, this entire sum will decrease. To make the sum constant, this has to increase, which means x has to decrease. So when y increases, x decreases. At the smallest value of y, we are getting x as 1. As we keep increasing y, x will decrease and become a value which is not a positive integer. And therefore, only one solution is possible when x is 1 and y is 5. Option B becomes the answer. I think moderate level of question, about 2.5 minutes to solve. The total number of integers xy that satisfy xy is equal to x plus y. This can be written as xy minus x minus y is equal to 0. Coefficients are minus 1 and 1. Multiply them. We get 1. Add 1 on both sides. So this is nothing but x minus 1 into y minus 1 is equal to 1. When will this happen? Either x minus 1 is equal to 1 and y minus 1 is equal to 1. Then the product would be 1 for integers, which gives us x is equal to 2 and y is equal to 2. This is one solution. Or x minus 1 is equal to minus 1 and y minus 1 is equal to minus 1, which gives us x is equal to 0 and y is equal to 0. Number of integer solutions, there are two solutions possible, 0, 0 and 2, 2. 0 plus 0 is 0, 2 plus 2 is 4. Those are my two solutions. Option C becomes the answer. Number of integer pairs. Easy question because the format is standard and the number is small. Also, the final value that we are getting is 1. So there are only two cases possible. Attempt time might go up to 2 minutes. David manufactures and sells a single product at a fixed price in niche market. The selling price is 30 units, rupees 30 per unit. On the other hand, cost in rupees of producing X unit is 240 plus BX plus CX square, where B and C are some constant. Mr. David noticed that doubling the daily production from 20 to 40 increases the production cost by 66, 2 by 3%. This in fraction is 2 by 3. However, an increase in daily production from 40 to 60 units increase results in an increase of only 50% in daily production. 50 production in fraction is 1 by 2. So from these two equations, we'll be able to find the value of B and C. Let us write the first equation. The production cost of 40 units will be 240 plus 40 into B plus 1600 into C. Putting the value of X as 40 here. This is 2 by 3 times more. So 1 plus 2 by 3 into the cost for 20 units, which is 240 plus 20B plus 400C. Putting the value of X as 20. So this will be 5 by 3 cross multiply 720 plus 120B plus 4800C is equal to 3 plus 1 to 5. 1200 plus 100B plus 200C, which means 20B plus 2000. This will be 5 into 400. 2800C is equal to 1200 minus 720, which is 480. Dividing by 20, B plus 140C is equal to 24. This is equation 1. In the second case, production goes from 40 to 60. The production cost for 60 units will be 240 plus 60B plus 3600C, putting X as 60. This is 50% more. That is 1 plus 1 by 2 times, which is 3 by 2 times. 3 by 2 times of production cost of 40 units, which was 240 plus 40B plus 1600C. Cross multiplying 480 plus 120B plus 7200C is equal to 720 plus 120B plus 4800C. 2400C B and B cancel is equal to 240, 720 minus 418. Therefore, C is equal to 1 by 10. If you put the value of C is 1 by 10 here, B plus 140 into 1 by 10 is 14 is equal to 24. So B comes out to 10, which means our production curve or the production cost is 240 plus 10x plus x square by 10. Assume the demand is unlimited and that Mr. David can sell as much as he can produce. His objective is to maximize the profit. What is the maximum daily profit that Mr. David can realize from his business? Profit will be revenue minus cost. For X units, revenue will be 30X. Cost will be 240 plus 10X plus X square by 10. We have to maximize this value, this entire thing. So this becomes 30X minus 240 minus 10x minus x square by 10. Taking 1 minus 1 by 10 common, we get x square. 30x minus 10x is 20x minus 200x. 240 taking minus 1 by 10 common is plus 2400. We'll complete the square here. Minus 1 by 10 into x square minus 2 into 100x. Therefore, add and subtract the square of 100. 10000 minus 10000 plus 2400. This gives us minus 1 by 10 into x minus 100 whole squared minus 7600. Again, multiplying by minus 10, we get minus 1 by 10 into minus 7600 is 760 minus x minus 100 whole squared by 10. So this is the profit, daily profit that you're having. To maximize the daily profit, you would want to make the negative term minimum. That will happen when x is equal to 100. At that point, this is 0. And the maximum daily profit will be 760. Option D becomes the answer. Again, in terms of level of difficulty, it is a moderate level of difficulty question. The attempt time, because of the solutions, might go up to 2.5 to 3 minutes. Right? If you look at the overall test, we are looking for about 6 to 7 questions in 24 minutes. For me, these question numbers would be 2, 3, 4, 6, 7, 9, 10. Which are these? Not counting this one because there were cases that are a little complicated. This I think was easier, checking for 0, 1 and minus 1. So counting this. This I think again was a standard procedure. Put minus 5, 5 and then take 3 cases. So counting this. I'm also counting this because we've done enough questions like this. We understand the values change at critical points, and from there it is easier to get the range. We don't have to check for the entire region. This again, there was a part of combination involved, so not counting this question as an attempt question. This I think was easy whether you put values or solve, either ways. This again, once you maximize Z, the other you maximize X, you get the two values. So I think I will count this question as an attempt question every single time. Here, breaking it down into the standard process was a little difficult, and therefore we were looking at values of x and y separately. So not counting this because if the terms are different, it might become something that I'm not able to do in the exam. This I'm counting because again the process is simple. Break it down into x minus a into y minus b and solve from there. And the constant that we are getting is 1. So the number of cases is just 2. Therefore, attempt question. This also is an attempt question for me because we've done questions like this earlier. And therefore, my 6 to 7 questions would be from 2, 3, 4, 6, 7, 9, 10.